Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about modifying a database using the structured query language or SQL. We will talk about the deletion of data from a database, inserting the data in various conditions, and finally updating the data on a database. When we are talking about modifying the database in SQL, we are actually dealing with the data manipulation language or DML. Now, when DML is concerned, we know that we are actually calculating the data relationship, not the schema. Say for instance, if we are deleting something from the database, all the structure of the database will remain there, only the values will go. Even if I am deleting the whole relation, then also the basic structure will remain there. Only the values of all the relation or attributes inside that table will go. So that is the thing we need to keep in mind while dealing with the DML or modification in the databases. So we will start with the deletion of a database on various conditions, complex queries and all. So the basic format to delete something from the database is this is the syntax for deleting something from a relation R. Delete from R. If I want to delete all the things, then I need to put a star over here so that I can delete all the records in the relation. Delete star from R means we are deleting all the tuples or records from that relation. Now obviously we do not want to delete all the records in a relation. We want to delete it on some various condition. Say for if some employees have left the company, that means their release date is greater than the start date and now of the current date, so that we can delete their existence or the records. By this way we can modify our delete record statement. So we will see in various cases that how to delete a statement. For the first example, we are considering a relation instructor where I am deleting all the records for the department name finance. So if there is anything of finance department, we are deleting all the records. Now say in the next one, I want to delete all the department names from the instructor relation where their salaries lie between 13,000 to 15,000, or say where the average salary of the department lies between 13,000 to 15,000. So we can use it like here I am first grouping down the relation by the department name, then I am finding the average salary of each of the department and checking it against the constraint that between 13,000 and 15,000, and then from the restricted relation I am deleting only the department name from the relation. So I'm using three parts that I'm deleting the name, finding the average salary, grouping it down by the department name. So all will be done in this order. In the next one, we will see some more complex. Now we will use some subqueries in the where clause while deleting a department name or any other attribute from a relation. Here look at this query. We want to solve the problem of we want to find the department names whose building is Watson and then delete records of the instructor whose department name lies or matches with the department name building of Watson. So first we are finding out in the inner query that we're selecting the department name where the building is Watson, which is a simpler one. Now I'm getting this department name as a set subscription of this one, that we are using the in clause. That means we are finding a set of domain values. We are getting a number of department names, and if my department name on the instructor relation lies within the department name of that Watson building, then I will delete all the tuples or records from the relation. See here, I am not using the star in every cases I want to delete all, because by default delete from relation deletes all the records in a relation. Now we can even use a nested select clause in a delete query. See here, I am using a nested subquery within the select clause that I am telling to delete all the records from the instructor relation whose salary is lesser than the average salary of all the university departments. So first we are finding the average salary from the instructor relation. That will find the average salary of all the instructors from all the departments. Now I want to delete the instructor relation records if the salary is lesser than this salary that we have calculated. See, sometimes the select statement in a subquery gives a set of attributes or a tuple consisting m attributes. Other than that, it can also provide a single valued relation which can be considered as a comparison to other attribute. So we need to keep in mind that this subquery should return only one single value. Other one is this numeric comparison will give an error that the non-matching patterns are there. So that is all for the deletion part. Next I will move to the insertion part. When I am talking about inserting something in the database, that are actual values that we want to store in the database. The insertion deals with the values, not the attribute name and data types. They are defined in the schema by the DDL. Now I want to put values against those attributes. Say for the salary, I can put 15,000, 14,000 if that is an integer. If it is a varchar, I can put the names or the employee ID like E01, E02. So these are the real values that we want to store in the database. So let's look at how to insert values in the database. The basic syntax of inserting a data in the database looks like: so this is the basic syntax of inserting a value that consists of insert into the table name, then the keyword values, and after that the data types according to matching the values accordingly. So sequentially we need to put the datas. So say for a relation that consists of 4 data types and 4 attributes and the relation name is course. So first let me define the relation. Say there are 4 attributes of the course relation consisting CID, CNAME, CSUB and the credits. The CID, CNAME, CSUB are all varchar and the credits codes for an integer. Now if I put wrong data types into wrong types of the attribute, then it will create an error and the insertion will not be possible. Say for an example, I am putting the values against see here when I am performing this, First, CS437 will go to the CID as it is a varchar. Same goes with the computer science and DBMS. Now for the credits, the data type is int, but here I am putting the 4 inside a single inverted comma. So that will be considered as a character, not an input. So it will create an error and the whole database will not accept the insertion statement. So we need to put it in the right order and with the matching data type, that of the attribute. And if there is specified some constraints, then we need to specify or satisfy the constraint too. So let us first see that what we can do with the natural insertion statement. If there lies by default some values in the schema definition of the attribute, then we can also skip the attribute value. Or again, we can skip the attribute's value if it can be left null. So we will just skip it and put a comma. Say suppose the CNAME can be left null and no constraint is there. So we can insert a quotes relation like this will be accepted by the DBMS or the database as CS47 matched with the varchar and considered as a CID. No CNAME is given here even if not a space. We cannot put a space here, just 2 commas one by one to indicate that there I don't want to put any value in the CNAME. And if there lies a default value while defining the schema, the CNAME will be considered that one. Say for an university has only one subject, that is the computer science. So we do not need to put the computer science in the CNAME. All by default computer science will there. And the subject is DBMS and the credits are in integer 4. So it is absolutely fine to insert a relation or a record in the relation error table. Now we will do some constraint checking and predicate checking while inserting a value. Now if there is a constraint mismatch or the ordering are different from this one, then there will be an error. Say suppose I have reversed the order of 4 and DBMS with each other. So now 4 is an integer which is not a varchar. So it will be an error. Again, the DBMS is also a character, not an integer. So it will be an error. So this type of ordering problem is there in the insertion we need to keep in mind. And if there is a constraint violation, that is if the CNAME can be only say 5 characters or 6 characters and we are making it a 7 or 8 characters, then also it will create a problem. So we need to define the data types properly, their sizes properly, constraints properly, and now the value and the ordering should be the same exact order of defining the schema. So these things we need to keep in mind. Now we can again insert values from some other relation based on a condition. Say there are exactly matching number of attributes in 2 relations. So why you are putting one relation values in another relation? Because you have some constraints and you have some predicates over there. Say there are 2 relations, department and instructor. Each of that has 4 attributes and the attribute data types matches with each other. It doesn't matter if the attribute names are different, but their types should match with each other. And now if there is data type matching attribute and the number of attributes are same, then only we can put some values from a relation into another relation. We will see how to do that. Now I want to put a value in the instructor relation, which is a value from the student relation with the ID, name, department name, and the salary as $18,000. Now I am selecting from the student relation these 4 attributes because the relation can contain more than 4 attributes, but the instructor has got only 4 attributes, that the ID, name, department name and salary. So if there is a student who has got all these department names attributes along with the predicate that their department name is music and total credit is 144, that means he is in the 4th year and he can now be considered as a visitor instructor in the department. So if the music department and credit is 144 greater than, then we can consider him as an instructor and putting his value as an instructor value in the instructor relation. So what we are doing, we are putting the name insert into instructor, and other than using the values or the relation name, we are actually putting a query here that select a number of attributes, and here I am making a default value that 18,000 will be the fixed salary. So I am not taking the salary, I am just putting 18,000 here. So maybe from the student it has not got any type of salary. Now I can put an extra attribute as a constant value 18,000 in the new instructor 1. So these things we need to keep in mind while putting value from a relation to another relation. Now the relation is containing predicates and joined over an AND clause. Now other than that we can put another relation just as same as the relation. This is known as copying a relation to another one by insert statement. Let us see that how to do that. See what I am doing here, I am appending all the relation on the records of the relation again in the relation. So if there is a set of records in the relation student, now I want to insert into the student the exact number of records that is also present in the student relation. So first the records will be displayed on the student relation, and then again that part of the set of records will be appended with the student relation. So it is actually duplicating the values so that I can delete it and the record will still remain in the relation. Now I will put some clauses and make it complex by inserting the values in the relation. The first type of complexity that we can put in a relation of an insert statement is putting a null value. If the attribute allows a null field or a null value, then while putting it we can use the word null to keep it null. See, other than the 3 attributes of the student relation, I am using the word null here. That means maybe it's a salary attribute and student has not got any type of salary, so I put null here. See the difference between null and leaving it empty. Null contains the null value and it has got some memory, but if I left it empty, there will be no value stored in it. The next part of our discussion goes with the updation of data. See, in the real time, if you are creating a database and storing and accessing it, often you need to update the database. Say there is a salary increment in a company, or a student has got new marks in the new exam and that has to be added to the database. So every time there is a possibility of updation in the database. So we need to deal with the updation of a database very carefully. First, we will deal with the basic update syntax. This is the syntax of an updation statement, that is update keyword followed by the table name, then the set keyword, the new value of the attribute equals to any updation or any function that we perform on the old value. Say it can be a plus, minus or any other functions that we can perform on an attribute. Say I want to half the salary of some instructor or every instructor. There is a fall in the company and I want to half the salary of every instructor. So how can I do that? So by doing this, I am using the instructor as the table name or relation name, and salary is the salary or the attribute that we want to modify, and I want to modify it by multiplying it with 0.5. That is why I'm making it half. So in this way, we can use the basic update statement. Now there are obviously more predicates, more clauses while we are updating some statement. So let us see one by one how to do that. Our next example specify that if the salary of an instructor is less than 70,000, then I want to update the salary. So I want to do it like this. See here I am using a where predicate with the update statement. So the basic thing to see is I can use the where predicate even if without the select statement. So I'm using the where as a predicate checking in the update statement. So I am updating the salary if and only if the salary is less than 70,000, and I can do it using the where predicate. Now I'll make it more complex. I will make it that the updation will be done if there is a range in the where department or a relation that I can refer in the where department. See, I can even if use an aggregate function and a subquery inside the update statement. What I am doing that if the salary of an instructor is greater than the average salary of all the instructors, I will do an increase of 1.05 to the salary of the instructor. So the updation is same as the previous one. Now inside the where statement, the salary is greater than. Now I am choosing a relation of a single valued attribute, and that attribute is the aggregate function on the salary attribute on instructor relation. So that is a query select average salary from instructor, and the average salary will be considered as a single valued relation which will be compared with the salary of that particular instructor. So in this way we can update the value of the instructor. Now say if there are two updation statement, if there is the salary lies greater than 10,000, then I will 3 times multiply the salary. If it is less than 3,000, then I will 5 times multiply the salary. So we can put two update statements like this, greater than 10,000 and less than 10,000, but I will show you that how to make it in a single query where two updations are possible. So here I am using a case, or that is more like an if statement of a C++ language. So I am updating the table instructor and setting the salary equals to not salary into 1.03 or 1.05, rather than we are using a case statement, case followed by when the predicate number 1, then the positive result of the predicate, else the negative result of the predicate. Now we can make it a nested or an even considering more and more predicates by using when predicate then positive result, when predicate then positive result, and at last we can note the else, that is if any of the condition is not satisfied. So I will do this one. So it is more like an if-else if statement inside a C++ construct. So here I am using two queries, merged it inside a single updation statement. Now I can even two relation natural join together and use this resultant relation as a reference to the updation statement. Let us see how to do that. Now I want to fetch and update the student's total credit if and only if the student has successfully completed a course. That means that he has not got any F in his total grade, that he has not failed any subject, and the total grade is not left null. So first, what are we doing? We are doing that statement update of student S. I am aliasing student as S and set the total credit as in subquery. That means I will credit of the total will be set as the sum of the credits of that particular student. Now I am natural joining two of the tables like text and course. Text is the table that contains the student that is taking the course and have passed the exam, and course is the course name. So if the text.id and the student.id match, that means the student has got an exam of that particular course. Now I want to check that text.grave is not equals to null and it also not equals to F. That means that the student has not failed and the grade field is not left null. Now in that condition I am summing up the credits and then updating the total credit of the student on this query. So we can even update an attribute based on a query. Now we can update an attribute based on the not null and null constraint too. Let us see an example. Now while I am updating the previous statement, we can use if the F condition is not there and only is not null is there. So we can use a case statement. If the sum credits is not null, then I want to make the sum credits as the updation, otherwise as the 0. So we can use the not null constraint in the when and case clause too. So that is all for the updation and the example. Practice it in your home. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.